So this is the last problems in the first part of the projectile notes that if we did not finish in your class to finish watching. So it says I throw an object off the edge of a cliff that's 15 meters tall. If I throw it horizontally at 8 meters per second, we're going to determine how much time it takes for it to fall to the ground, how far from the base of the cliff it hits the ground, so another way to say that is the range, and determine how fast it is moving vertically when it hits the ground, so the final velocity. So to determine how much time it takes for it to fall, we're first going to list what we know horizontally and what we know vertically. So they said it was launched horizontally at a velocity of 8 meters per second. So over here in my horizontal column, I'm going to write my velocities 8 meters per second. And since it was launched horizontally at 8 meters per second, there was no initial velocity vertically. So we can say that the initial velocity is 0 because it wasn't moving up or down. It was just launched horizontally, which is left or right. And we were also given that the height of the cliff was 15 meters tall. So that goes in my vertical column. As the projectile is launched, it's going to speed up as it falls down to the ground. So you can either make your delta x, your velocity, and your acceleration in your vertical column either all positive or all negative. So I'm going to choose to make all my variables positive. Also, as it's released, it becomes a free fall problem, making my acceleration 9.81. And also we've talked about that the horizontal velocity is constant, so there's only one equation that we will use over here in this horizontal column, meaning we're only going to have 3 variables in this column. In my y column, my vertical column, you can have v naught, delta x, a, vf, t, any of those variables in your acceleration formulas. So it wants to determine how much time it takes for it to fall. So I don't have enough information horizontally to solve for the time, but I look in my vertical column and I have a v naught, a delta x, and an a, and I could use one of my acceleration formulas to solve for the time vertically. And I know the amount of time that it takes to fall vertically is the exact same amount of time it's going to spend in the air horizontally. So if I know this time, I also know this time. They're the exact same amount. So I'm looking at my acceleration formulas, and I'm going to use delta x equals 1/2 at squared plus v naught t to solve for the time. So the height of the cliff was 15. 1/2 times 9.81 times t squared plus 0 times t, which that is just 0. So if I calculate this out, I get a time of 1.75 seconds. So it gives me the time here. It also gives me the time here. B wants to determine how far from the base of the cliff it hits the ground. So it's asking me to solve for the range. How far does it go horizontally? And again, since the velocity horizontally is constant, there's only one equation for constant velocity, which is x equals vt. So that's the equation I'm going to solve for, and x is distance. So I take that velocity they gave me in the problem. We just solved for the time, and we get a range 13.9899, so I'm going to round up to 14 meters. So from the base of the cliff, it's going to be out 14 meters from the base of the cliff. The last one says how fast is it moving vertically, so it's asking me to solve for the final velocity. So I look at my acceleration formulas, and this formula jumps out at me. The final velocity is what we're going to solve for. The initial velocity, there was no initial vertical velocity, and my acceleration is 9.81 because it was free fall, and we solved for the time 1.75, and you calculate that out, and we get a final velocity of 17.17 meters per second as it hits the ground.